Okay, here's our question. What is the number of valence electrons in an atom of element number 35, bromine? Valence electrons are pretty important. We'll need to find what the number of valence electrons are to do any type of explanation of covalent bonds. So you'll be doing this a lot. So our first step is going to find or to write the electron configuration for the element. Now the electron configuration for number 35, bromine, is argon, 3d10, 4s2, 4p5. Let's review that by using the periodic table. Here we go. Here's the table, and here's bromine on our periodic table. I've included the subshells and energy levels in the periodic table, which are pretty logical. First energy level, second energy level, going from the S subshell to the P subshell. Third energy level, same thing. Fourth energy level is a bit unusual. We have an intervention of these 3D transition metals. The transition metals energy level is one less than their horizontal row. Something to remember. So we would come up with the electron configuration of bromine by looking for the noble gas that comes before bromine, argon, which has 18 electrons in it and counts all these previous electrons. So it takes care of 18 out of bromine's 35 electrons. Now we move forward, we go through the 4s, that's 2 more electrons, 4s2. Then we go through this again, jump down to the 3d. 3d with 10 electrons, 3d10, and then 1, 2, 3, 4, 5. Bromine would have a 4p5. And when you add the 2 plus 10 plus 5, the 17 electrons to argon's 18, you come up with the 35 electrons you'd expect to find in bromine. So let's go back to that electronic configuration again. And here we are, argon, 3d10. Again, we put it in a numerical order of energy level. 4s2, 4p5. All right, now being back to what are the valence electrons, not the electronic configuration. What are the valence electrons? You count the number of electrons in the uppermost energy level. That's a little tricky because you're going to have to ignore those 3d10s. So that's going to be relatively simple because 2 electrons in the S, 5 electrons in the P adds up to 7 valence electrons. So there you go. Now that took a while, and you're going to be having to find valence electrons pretty often. Now there's a shortcut to this, and that's to use the periodic table. Periodic table, the columns will always tell you what the number of valence electrons are. Bromine is in column 7 valence electrons. That's not a coincidence. Anything in the alkaline metals is 1. Anything in the alkaline earths is 2. Our family for boron is 3. Our carbon family is 4. Our nitrogen family is 5. So nitrogen, phosphorus, selenium, tellurium, all of them would have only 5 valence electrons. Those are the top valence electrons. And of course, our halogens are going to have 7. So number of valence electrons is as simple as counting up to 8. 1, 2, 3, 4, 5, 6, 7, 8. Helium's an exception because the first energy level doesn't have any p subshells in it. It's only got 2 valence electrons. Our transition metals are a bit unusual because they've got their d orbital electrons 1 energy level less than you'd expect. So surprisingly, all the transition metals will have either 2 or sometimes 1 valence electron. In fact, that's why the transition metals are so similar, because they have the same number of valence electrons. Answer to our question, 7 valence electrons, which you could have gotten just by looking at the periodic table. Your friend.